What about now? Can you hear me now?
No.
Can't hear me. Cannot hear
Yeah.
me. Yes, yes. Is
I
it
can.
is it loud enough? Should I go louder? How's that?
I think a little bit louder. There's a lag between real time and you.
Yeah, it's
So
gonna have like a probably 20-30 second lag. How's this volume level? I don't want to be yelling, but the people gotta hear the voice.
louder.
Louder?
Yes, louder.
Oh, that's very quiet. I think it's because this microphone is so far away, which is not good.
That's good.
Okay, that's topped out, so that's the best it's gonna get. All right, get you an in-house audio technician. Unsolved. Okay, tickets to the Blue Jays game are $14 for every. What ticket price will generate the maximum revenue and identify that? I don't want to do that. That sounds boring. Practicing past papers and I can't do this. Okay. Oh. Well, that's actually pretty legible. Let's see. Did anyone? Okay, somebody answered that. Come on. What are we gonna do here? Relative frequency distribution. No, thank you. Oh, a Fourier transform. We're covering Fourier transforms in my computer science class. And I'm having a bit of a struggle wrapping my head around the concepts. Yeah. One of my homework questions asks us to compute the Fourier transform for the following function. Question. Oh, we linked it. Love that. Okay. There's just no way I'm doing this. X minus k. Okay, yeah, definitely not doing it. Use the for. And e to the ixt. Oh, they use a different. No, not doing it. How do I go about this? Post image. Between this bar, what number is it? 13. Use technology. Okay, that's how you do it. Consider the polynomial. All right, this is probably interesting. Where c is the constant determinant value of c such that the graph of the function has each number of x-intercepts. Oh, interesting. Interesting. Well, if c is 0, it would be 3. Yeah, yeah, I'm just gonna do this. Okay. Question in my live stream starting at. When am I starting at? Okay, so I need to make that window pop out. So we're 5 minutes into this and I haven't done anything yet. 5 minutes into it. I'm going to use technology since that's what the instructions say. This, boom, boom, paste, insert, go. All right, so let's do this. me make sure I've got the right thing going on. Okay, OBS, we're ready. So import, add. All right, did it come? There she is. All right, this is use technology. So I'm gonna actually use technology. I need to add a scene here in OBS. Oh no, that's terrible. That's not what we want. Oh, that's because I need to put this in studio mode. How do we go to studio mode? View, studio mode, studio mode, studio mode. Scene collection, tools. View, sources. I need an adult. Studio mode. Okay, so that's good. This is going to be next. We're going to add a window, and I actually need to create that first. Calculator. Boom. Add. Cancel. Add. Window capture. Okay. Desmos. All right, so that's good. We want to make you the fullest of screens. I guess, I don't know. This is gonna look funky because the window, for whatever reason, is not like the same ratio as this thing. Okay, whatever, this is enough playing around. I don't usually do this kind of stuff. Let's transition. So, on the live stream, we should be seeing the same thing. Okay, we got Desmos. So our question says, consider this polynomial function. So let me type that polynomial function into Desmos. I'm going to say f of x. You don't always have to use this f of x in Desmos, but if you want to like reference that function later on, it's actually pretty helpful. So I've been doing it more and more there, because I'll think about it later if I want to do that. Now, so this is good. Then you can do plus c, and when you do that, you get this option to add a slider. So I'll do that. Okay. Now, how many intercepts do I have here? Right now, c is 1, so let's set c to 0. And okay, when c is 0, I've got 3 intercepts here. I'm going to actually click here and change this to be like, I don't know, -10. Oh, that's 0.10. -10 to 10, and I want my step to go by 2 because I don't want to play around too much with this. Okay, I don't know if that's going to work out though. So that's 4. So anything less than c equals 0 gives you 4, and then 0 is 3. So c less than 0 gives you 4. C equals 0 gives you 3. C greater than 0 gives you 2. And then, okay, we need to adjust the upper bound here. Let's go, I don't know, 30. And somewhere in between there. So let's make the step back to 1. And I'll just go like -2. Okay, come on, that's 0.2. -2. All right. So when c equals 0, we have 3. When c is less than 0, we have 4. And then when c is equal to, what does that look like, 17? We might actually need to solve that manually because it doesn't look like it intersects there. No, it doesn't. Let's go 0.1. See, the issue is this is not going to like go perfectly. Yeah, even 0.1 jumps it over. Oh, so it's 0.3. Anyway, we can figure out that exact value for 1 and then 0. So I'm going to write these in the other window. C less than 0 gives us 4 intercepts. C equal to 0 gives us 3 intercepts. And then C greater than 0, or actually let's do 0 less than C, but C is greater than some value, I don't know, K. I don't know what K is yet. Gives us, no, we do, yeah, so there's an upper limit. This gives us 2. And then C equal to K, whatever that is, we don't know yet, gives us 1, and C greater than K gives us 0. And I know you can't see what I'm writing, but here's the idea. You use technology, which in this case I'm using Desmos, which is a very capable website. So if you don't view this as technology, something like needs to change about your perception. So when C is negative, I get 4 intercepts. When C is exactly 0, I have 3 intercepts. When C is greater than 0 but less than some value, which is going to be around 17, I have so between between C equals 0 and C equals 17-ish, I have 2, and then when I get to 17-ish, I have exactly 1, and then greater than 17-ish, I have 0. So we need to figure out what that 17-ish number is. I'm going to go ahead and transition my view back to this, and I've written all that information down here just for myself, but let's see how I can find this out. I like really want to always be able to solve things manually so I could get an exact value. I don't like approximations. It just, for whatever reason, it's an aesthetic thing. It bothers me. So I'm going to see if I can work this out. This right here is too much work. This is way too much work. If you wanted to do less work and just, go back to Desmos or whatever you're using, whatever technology you're using, and lean way into this. So I'm going to change my values here to be like 16.7 and 17, okay? And I'm going to step by like 0.001, I don't know. And then I'm just going to like really move this down slowly until I get that intersection right there. So, this isn't 2.243. Like, it's approximately that. Is that exactly it? No. This is ridiculous. This is not how things are done. Okay, so that's not even right. Let's go less. But, is this enough that I'm going by tens, hundreds, thousandths of a place at a time? Yeah, I don't know. It depends on your teacher. Let's go 4 decimal places. Why not? Let's be crazy. And we'll go like 0.85 to 17. Okay. It looks like right there somewhere, Now there's 3. Or now there's 2. So it's like somewhere in this vicinity. 16,947. For me, that's not good enough. Like, I want to know what that value is. But K is like approximately 16.947. So if that's good enough for you, stop the video right now. Like, go, give me a like and a subscribe and enjoy the rest of your evening. But I want to know how to make it so that there's exactly one root on this thing. All right. And just a disclaimer, like, I may not even be able to do this. So the way I'm going to do this is I'm going to FOIL this all together. So let's go. I'm going to FOIL these first two. X squared, we're going to go minus x minus 3x, so minus 4x plus 3. Then this is times x plus 2 squared, which is x plus 4x plus 4 plus c. And I'm going to distribute this again, so I'm going to get x cubed plus, x cubed plus 4x, no. So I'm going to distribute this to every term. That's where I'm going first. Minus 4x squared plus 3x. I'm going to just distribute 4x to every term. Plus 4x cubed minus 16x squared, and plus 12x. And then I'm going to distribute 4 to every term. Plus 4x squared minus 16x plus 12. So let me check that. We're going to go x cubed minus 4x squared plus 3x. Then we're going to go plus 4x cubed minus 16x squared plus 12x. Then we're going to go plus 4x squared minus 16x plus 12. Okay, that looks good to me. And then I can add the c now. Now, keep in mind that this is supposed to be equal to 0. And it's supposed to be equal to 0 exactly one time. So we need one root here. Let's combine some like terms. And this should be, oh, goodness. That's a squared. Did I mess that up the whole way through? Yes. Yes, no, maybe so. I did. Okay, so I'm going to just do this again because I made a mistake. And I want to make sure that I'm good here before I start going further. Okay, so x to the 4th minus 4x. Yeah, I did that all the way through. Good catch. All right, so we've got x to the 4th minus 4x cubed plus 3x squared. Then we've got plus 4x cubed minus 16x squared plus 12x. Then we've got plus 4x squared minus 16x plus 12. And plus c equals 0. All right, still might be wasting your time. Just give up now. Just stop paying attention. So these guys cancel. That's always nice. Then we've got, let's go with x squareds now. That's going to give me 1. Okay, so then these 3, so that's 7 minus 16 is negative 9x squared. Then let's go with x's. That's going to give us minus 4x and then plus 12. Okay, so what can we do with this? Who knows? Plus c equals 0. That is very interesting. So what I'm thinking is that if, hopefully I'm on the right window. Oh my goodness. I've been talking this whole time. Nobody's in the chat telling me I need to transition. All right, thanks. It's my fault. Let me stop blaming everybody. All right, we're good though. We're good. So basically, let me just kind of sketch through what I did here. I foiled these together to get this term here, and then I squared this to get this term here. Then I distributed that together to get this whole mess, and then I combined like terms, and I've got this. Now, why did I do this? I wanted to see if this would come out in a form that it would be possible for me to do something with. There's no like guaranteed way to get there's no guaranteed way to solve this fourth degree polynomial equation, but I'm thinking maybe if I could like do a change of variables and get this into a quadratic, then I could use the quadratic formula. But maybe there's an easier way here. So what if I guess one? I know I want x to be near 17. Can I use that information? No, I want c to be near 17. I want c to be near 17. So what is the x value, though? X is like 2.2. 2.2247. That's very interesting to me. What could that be? Okay. This is why it's a technology problem, because it probably doesn't have like a nice closed form solution that's easy to get to. I think I'm going to abandon this one just because the stream's getting boring unless someone pops in and is like, hey, bring that question back up. So like, I'm going to tuck this away. Because I think, like this may yield to trying to do some weird like complete the square situation to this, and then do a change of variables, get this into a quadratic, plug it into the quadratic equation. But I don't really want to go through that whole mess because it doesn't feel satisfying to me right now. But I will save this. I can just bring it back. There it is. All right, I'm going to go attack an easier problem that I can actually like make someone's day on. But anyway, let me give you this. Like it's ish. This is it. So your answer is like, when c is negative, you got 4. When c is equal to 0, you got 3. When c is between 0 and k, you got 2. When it's equal to k, you got 1 exactly. When it's greater than k, you got 0. And it says justify it graphically. So do a sketch of that graph as c goes up and down, and just take like the x and y intercepts and forget everything else. Maybe the maxes and mins. Okay, go on to another question. You refresh this so I can see. Boom, you go away. How do I derive net of rectangular prism? Oh, given the surface area. Yeah, I don't want to do nets. Need some help with this run. No. Boolean expression, that's cool. Link to image. Need help on how to solve this. My professor doesn't teach this well. Yeah, that sucks. Paid a lot of money for that, I'm sure. Simplify the following Boolean expression functions algebraically. So this is A complement plus B complement. Oh, I wonder if I can even do this. That's fascinating. Boolean functions. Oh, let me Google real quick. So, Boolean function notation. Is non, and n is a non-negative integer. Okay, it describes how the way how to derive Boolean output from Boolean inputs. Let f equal. Okay, this is a function. Oh, do we even? I just don't need it. Attribute 2 from the set of ordered pairs of Boolean variables to the set where f00 equals 1. Why? Oh, so 1 times 1 is 1. 1 times 0 is 0. Oh, so is it and? It's and. F11. It's XOR? No. Oh, here's the identity. So, not, yeah. Plus is or, times is and. What's up, Evans? I don't know what that means. What does fum mean? Identify law. Or identity law. Okay. Dominance law. A plus 1 equals 1, 0, or 1 is 1. A and 0 equals 0. Okay, commutative, associative, simplification, A times. So A and not A is no, or A and B. Okay, that makes sense. So not A and B is A or not A and B. So if it's A, then it's yes. You know, this is, I don't know as much about this as I think I knew, or as I thought I knew. I'm not doing that. How do I get the other 2 zeros? I understand plus 1. Okay, this has 6 comments. I'm gonna just go with stuff that has no comments. Oh, this is maybe a bad time to go live. There's no good questions right now. Quadratic form and orthonormal vectors can help me with this topic. I managed to calculate all I needed, but with U in V, such as eigenvalues and eigenvectors, I do not really get the point on the without calculating U and V. Okay. Quadratic form. Is 3 times 1 squared plus 4. No. Integration. Linear algebra question. Doing the join of a matrix and doing cofactor expansions. That when you say you don't actually multiply the determinant by the number you are getting the cofactor of. Doesn't involve cofactors. Do you mean the adjunct? Okay. Okay, yeah, I probably should have done this hours ago. Alright, well, let me check the other subreddit. Homeworkhelp. Filter by mathematics. Why is this not working? Okay, whatever. 8th grade factoring polynomials. Whoa. Oh, it's a Y. 6x squared plus. Okay, well. telling this person about to start their thing. Oh man, got a whole lot of nothing done in 31 minutes. Okay. All right. Import, add image, boom, boom, boom. Okay, so here's this problem. So I'm going to rewrite this because this is very hard to read. And I'm not saying that to be mean, but, you know, even if you have bad handwriting, right? Like if you're naturally going to have worse handwriting than other people, that's a real thing. Some people have bad handwriting. You can improve your handwriting as far as you can improve your handwriting. And you should try to do that. Like what you see here, my handwriting is not unimpeachable. It's not that great. But I work really hard to improve it every day. Like I think about that as I'm writing. Because you don't do math for yourself. You do it for the community. Okay. So anytime I am multiplying monomials, which are single term, you know, things, okay, coefficient, variable, exponent kind of situation. Like this is a trinomial, so it's 3 monomials. Anytime I'm multiplying these or factoring them, I have a specific order. I think sign, meaning positive or negative, coefficient, meaning the number out front, and then I think variable, 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 and there's however many variables are in there. Now that order simplifies things for me a great deal. So first since this is the highest degree term and it's positive, all my factors are going to be positive. That's what I'm going to pull out, okay? Now I'm looking at coefficients, 6, 30, and 28. I need to find out what's the greatest common factor of these things. And it looks like you found that already. You chose 2. So just quickly, I'll factor these over here. 6 is 2 times 3. 28, let's go birthday cake method, 2 times 14. 2 times 7, so it's 2 times 2 times 7. And then 30, we can birthday cake that guy as well, 2 times 15. 3 times 5. Okay, so our GCF is going to be, we have 2's in common everywhere, and that's the only one that we have in common everywhere. So we're pulling out a 2. Now I got to think about what variable is in common everywhere. This is a lot easier. I see this has 2 factors of x. This has 1 factor of x. This has no factors of x. So there's no common x. 1 factor of y, 1 factor of y, 1 factor of y. So there is a common factor of y everywhere. So let's pull that out. Now, this part some people find a little bit difficult, but you have to put the other factor. So 2 times what equals 6? 3. So I put my 3. Now, I did not factor out an x squared, so that x squared is still inside there. Then what times y equals y? Well, 1, so I'll just, there's nothing there. 2 times 14 equals 28. Then we've got a factor of x, and then I took out the y, so we'll leave that alone. And then 2 times 15, and we took out the y. So that's factored. Now, you got that far, I think. Let's check what you did. Oh, interesting. So you broke this into 9, and so -9 and -5. And I'm not sure why you did that. So let me think here. You have x plus 1 and 3x plus 15. No, I don't. This is not correct. So if we were to multiply these back together, so let's check. So I'm going to change the color so we can see this is kind of like an aside. So you have 2y times x plus 1 times 3x plus 15. And if I FOIL these 2 binomials together, we would get 2y times 3x squared, so first, outer, plus 15x, inner, plus 3x, and last, plus 16. And this is not even close to this guy here. So that doesn't super work out for us. Can we factor that, though? Well, I don't know. Let's find out. It's a quadratic, so you can always use the quadratic formula, but let's see. So I think we need like a 3x and an x. The factors of 15 are 1 and 15 are 3 and 5, so we could try 1 and 15. This would be 3x. We get, no, it's way too big, so that's not going to work out. Let's try 5 and 3. Or 1 and 15. Let's do 1 and 15 first. So 3x squared plus, no, that's not going to work out. So then let's try 3 and 5. Boom. 15 minus 3. No, that won't work out either. This needs to be positive anyway. Oh, maybe this will work. So 3 and 5 here. Negative, negative. So 3x squared minus 9 minus 5. That's the 1 plus 15. So that's the factorizations. So let me not be so like glib about this. So here's what I do. I know that when I FOIL something together of this shape, like some number times x, some number times x, plus or minus, right? Plus or minus some number, plus or minus some number. I know that when this FOILs together, that the second, like this coefficient multiplies with this coefficient and gets this number. So I know I have a 3 and a 1. Has to be 3 and 1. That's the only way you can multiply two numbers to get 3. It's a prime number. Then I know this number and this number multiply to be 15. I also know that it has to be positive. Okay, so I either need two positive numbers or I need two negative numbers. Now, in this case, it has to be negative because they need to add together to be negative 14. So only two negative numbers can add to be 14. Now, the only thing to do is factor 15. So I know 1 and 15 multiply together to be 15. I know 3 and 5. So I have to start thinking about ways that these will multiply together once I FOIL it back. So I'm just thinking about how foiling works in order to decide how they go. Now, you can guess and check this. You can try 1 and 15, 15 and 1. See if they work. They don't. You can try 3 and 5. See if they work. They don't. Try 5 and 3. Oh, there, that's the one. That's the process I went through. I was very unlucky. The last way I checked it worked. Okay, now I got to drop down my 2y. That's fully factored. This is the answer. Box that. I think that's the whole. Let me read your deal. Yeah, okay. That's all you asked. So this is our factored form here. Hopefully it helped. Have fun. And if so, smash that subscribe button. Let's see if I can find another one. New. Oh, that's why. Okay, 6th grade math. How do I drive? No, definitely not doing that. Find the limit. All right, maybe. So I have to find the limit for this function, but I have no idea how you do it. I know we need to expand the denominator using the sum of cubes formula. Sum of cubes formula. What is the sum of cubes formula? Let's Google that. Sum of cubes formula. Sum of cubes. Oh! Why do we need that? Interesting. Okay, let me try this. So, working on your problem in my live stream, starting at, what am I starting at? 41 minutes, 41-ish minutes. Okay. All right, so I got a question, and this question says that the poster says, the OP, if you will, says that they need to use the sum of cubes formula. They know that they need to use the sum of cubes formula. I'm not sure how that's going to play in here, and I'm kind of worried that if I start thinking along that way and they don't actually need to do that, that it might pull me off some more obvious path. But, you know, I'm going to just like take a second and sit with that and see if I can make that make sense to me. And so this is x minus 1 squared. Okay, so I rewrote my roots, or surds as they call them in some parts of the world, into rational exponents, because sometimes I find in calculus that makes whatever problem you're working on, it makes it clear. Like for integration, you can use power rules, and yet for derivatives, you can use power rules or whatever. So I like this form a little better sometimes. So then I'm going to expand the denominator also. So let's make this limit as x approaches 1 of, so we've got x to the 2/3 minus 2x to the 1/3 plus 1, and we're going to go over, x squared minus 2x plus 1. Okay. Why did I do that? So my thought is that I can do long division here, and then I'll get this down to a rational function, which I should be able to plug that in. Let's see. So I'm going to go x squared minus 2x plus 1. I'm going to divide that into x to the 2/3 minus 2x to the 1/3 plus 1. Okay, so doing long division, what do you multiply x to the 2/3 by in order to get x to the, or I'm sorry, what do you multiply this by to get this, right? So the idea is like x squared times k equals x to the 2/3. So I just divide, and I find that x squared, or x to the 2/3 over x squared equals that thing, which is x to the 2/3 minus 2, just using an exponent rule, and which is, so 2/3 minus 2 is 2/3 minus 6/3, so we get x to the negative 4/3. So this is x to the negative 4/3. Let's see how this goes. So when you multiply it back, you should get x to the 2/3. This should be so times this would be negative 2 x to the 3/3 minus 4/3 is negative 1/3, and x to the negative 4/3. So these terms don't line up perfectly, so I'm just gonna move this. So this is plus 0, x to the 1/3 plus 0, and then it goes down to 0x to the 0. Oh, that's that term, plus x to the negative 1/3. You know what? I don't like this. I don't like this at all. Okay, I'm gonna go with my other thought, which was I'm going to do a change of variable. So leaving it in this form, what happens if we say x to the 1/3 equals y? If we do that, as x approaches 1, y approaches 1, since the cubed root of 1 is 1. So this becomes the limit as y approaches 1 of y squared minus 2y plus 1 over y cubed minus 1 squared. I don't know if you know L'Hopital's rule. I think this would be pretty easy with L'Hopital's rule. Would it be? Boom, boom, boom. Yeah. Yeah, I think so. Yeah, let's use L'Hopital's rule. So I'm going to take the derivative of the top, and I'm going to take the derivative of the bottom independently. This is L'Hopital's rule. This is not the quotient rule. I'm going to take the derivative of this, I'm going to take the derivative of this, and it'll have the same limit. And we're going to apply this several times, actually. So the top will be 2y minus 2. The bottom will be 2 times y cubed minus 1 times 3y squared minus 1. Do it again. So we've got limit as y. And actually, you know what? Just before I do this rule, I'm going to rewrite this as a square. So limit as y approaches 1, y squared minus 2y plus 1 over, this will be y to the 6th minus 2y cubed plus 1. Okay, that'll be a lot easier to take the derivative of. So now we're going to take the derivative of the top and the bottom. We got 2y minus 2 over 6y to the 5th minus 6y squared. And we will do it again. Oh, can we actually do it? So, okay, let's do it again. No, because this is not. Yeah, this is 0 over 0. Okay, so we're good. So we've got limit as y approaches 1 of 2 over 30 y to the 4th minus 12y. Okay, so I don't think I can do it again here. But can I factor this to be helpful? Y times 30 y cubed minus 12. That'll do. There's no problem with this. We can plug 1 into there. So we can solve this by simplification, or by substitution. So it'll be 1 times 30 minus 12, which is 2 over 18, which is 1/9. Let's see if that makes sense from here. Maybe. I don't know. Let's check it graphically. So I got this Desmos window. Crita. Let's go to OBS. Transition. And so hopefully this will be. So y is 1/9. Or the limit as y approaches 1. Gives us 1/9. So that would mean since x was equals y, that means we have the cube root of 1/9, whatever that is. But let's try it. So we've got x raised to the 2/3 minus 2x raised to the 1/3 plus 1, and this is all divided by x minus 1 squared. And then we care about what's happening as x approaches 1. And so it's undefined there. But we can look at a value like just to the left of it. And is this approximately the cube root of 1/9? Let's see. So I'm put on my calculator. 1 divided by 9 raised to the 1/3. No, it is not. So that is wrong. Let me go back and see what the hint was that I gave. Or I shouldn't assume. Alright. So I have to find the limit for this function, but I have no idea how do you do it. I know we need to expand the denominator using the sum of cubes, yet I have no idea. Expand the denominator using the sum of cubes. That makes no sense to me. Okay. So let me change OBS back. Let's go here and try to attack this a different way. Okay. Let's think about this. So I'm still going to write this as rational exponents. So this is x to the 2/3 minus 2x to the 1/3 plus 1 over x minus 1 to x minus 1 squared. And I'm going to multiply this by 1. So that'll be x cubed over x cubed to get rid of these. No. That won't work. Let me try that change of variables again. So just 1, this will be y squared minus 2y plus 1 over y cubed minus 1. Oh, that's got to be it. Is it? So this should be y squared minus 2y plus 1. Okay, I think I see it now. Let me just make sure. Where did it go? So this is so then, okay, so -1 equals -1 cubed. That's why. So this is going to be y minus 1 times y squared plus 1 y and then plus 1, and that's still squared. So, oh, tight. So we can get a cancellation. That's cool. I don't think I would have seen it in x. So y squared minus 2 plus 1 is actually y minus 1 squared. And then here I can just use an exponent rule to make this y minus 1 squared times y squared plus y plus 1 squared. These cancel. You get limit as y approaches 1 of 1 over y squared plus y plus 1 squared. This you can evaluate by substitution. If I get the same answer, I'm going to be so mad. So this is 1 over 1 plus 1 plus 1, which is 3 squared, g, which is 1/9. So as y approaches 1, whatever this function is, let's call it f of x approaches 1/9, or f of y approaches 1/9, which means, yeah, is that right? Of course it is. Why did I even convert that back to x? I was right. Both methods were correct. That's so annoying. I can't believe I did that. Anyway, 1/9. 1/9 is the answer. You could if you were like really good at algebra, you could probably do this without changing the variable too. But yeah. Oh yeah, because you could see it from like x equals x to the 1/3 cubed, and then that would be the difference of cubes there, or the sum of cubes, whichever way you want to think of it. Okay, let's see if I can find an easier one. I'm feeling like kind of lazy and almost tired enough to stop. Maybe a physics. Okay, cool. So that helped whoever that was. So that's cool. Let me actually want to go. Oh. I don't know if I'm going to be able to do this harmonic motion one. Oh, this is such a bummer. The limit one, somebody came in and just like typed it out. Why would y be cube root of x? Oh, yeah. That sucks. Okay. Let me edit this. Yeah, that's cool. This is like a really good subreddit. If no chemistry, I don't know what I'm doing wrong. Okay, let's do this one. Post. Working on your problem in my live stream. When did I start? I started at 1 hour. link, paste, insert. Okay. Import, add. All right, there's that. Okay, so determine the points, if any, at which the graph of the function has a horizontal tangent line. So what is a horizontal tangent line? Well, that's when the slope is equal to 0. So we have to think about the slope of this function being the derivative at that point. Okay, so we got to find out where we have a horizontal slope. So we say y equals x squared plus 3. Now, if you get a new question on this, I forget what this one is called. This is the, not Pearson, but the other textbook company. I use this one at my college. If you get a new problem, the only thing that's going to change is 3. So I can do this as 3. Maybe it'd be better if I do it as a constant, but I guess not. Let's do it for 3. You can just follow the example and change the 3 to whatever number you have. So the derivative of this thing is going to be dy dx. This is the derivative. You might write y prime. I don't know what notation you're most comfortable with, but it'll be 2x. Okay? So we need to figure out when is 2x equal to 0. We have to solve this equation. That's the equation we need to find. Well, it's when x equals 0. So when x equals 0, we have a horizontal tangent line. And that makes sense because this function is just a parabola shifted up to x or y equals 3 there, right? So that's where our horizontal tangent line is. Okay, so y is equal to x squared plus 3, which is equal to 3. So that means the point 0, 3 is on our graph. To determine the points, determine the points, if any, at which the graph of the function has a horizontal. Oh, that's the answer. 0, 0. You don't need to enter the parentheses, just enter 0, comma 0, I think. So the answer is, oh, no parentheses. The parentheses are there already. Or 0, 3. Whew. Almost told you the wrong answer. 0, 3 is the answer to that. Oh, I didn't even post it. Oh man. Okay, anyway, I'll leave that up while I look for the next one. If you pop in, then that's embarrassing. Do we want to do physics? Nope. See what else we got here. Consider a rectangular prism having a volume of 81 centimeters cubed. If the prism is composed of cubes of same length, 3 centimeters, okay. Oh, that's interesting. Oh, let's try it. Okay. So, working on the problem in my live stream. When do we start? Minutes in. Boom. Let's go hyperlink, paste, insert, actually comment. Okay, and here comes our question. Okay, so first let me take a second to roast you, dude. Just take a screenshot. You're on the computer. Like, take a screenshot of the question. Looks like you got Chromebook, you know? I think it's like, I don't know. I don't know the hotkey. Anyway, we got a rectangular prism. So let's imagine that we have a rectangle. So this is a rectangle. And I'm not drawing like a a rectangle shape purposefully because I want to give you a sense of perspective. So imagine that's a rectangle. These are little right angles in here. Okay. Right angles everywhere. You get a right angle, you get a right angle, you get a right angle. Okay, just imagine. And then, actually I might even take those out. I don't want to leave them, but just, they're right angles. Take my word for it. We take this guy, we copy it, we paste it, and we move it up. Okay, so I kind of like extrude this shape here. And then I'm going to go again and connect these. So this is my rectangular prism. So just imagine that this is a little square looking than it is. Okay. These angles are also right angles, so is this angle. Everything's a right angle. So this is my rectangular prism. Now I know that the way you calculate this is you have x, y, and z, and the volume of the rectangular prism is equal to length times width times height, which is x, y, z in this case. Okay, and I know that this has to be 81 centimeters cubed. Now, whatever unit of measure it is, it's going to be cubed because it's a length times a length times a length. So I'm just going to ignore that and think about how do I get 81 out of this thing. So it tells me that we, if the prism is composed of cubes of the same length, 3 centimeters. So I need to think of how I can get 3 times 3 times 3 in some way, or like something to do with 3's multiplying together so that I get 91. So or 81. So if 81 divided by 3 is 27, and then 27 divided by 3 is 9. So what if I did like this equals 3, this equals 3, and this equals 9? Okay, so this would be like 1 cube by 1 cube, or so it'd be 1, 1, and 9. Does that make sense? Oh, let's even think of it more basically. Like, we don't even need to go there. If each individual cube is 3 centimeters, 3 centimeters times 3 centimeters times 3 centimeters, this is 9 centimeters cubed. Okay, how many of these do I need to make 81? Well, 81 centimeters cubed divided by 9 centimeters cubed per like individual cube, and maybe I should explain that a little more, equals what? 9 times 9 is 81, so 9 cubes. So the idea is like you have this prism, and then it's actually made up of little individual cubes. So I'm going to do like one section of cubes. So there's some number of little cubes in here. Oops. And we don't know how many of them are, but I can calculate the volume of one of them because they all have the same volume. And then I just divide it by the total of the whole prism. So this is a terrible drawing job. Actually, that's not too bad. I'm pretty proud of that. Look at me. Yeah. Okay, so there's a bunch of cubes. They go all the way up through this drawing. And how many of them do we have total to get 81 centimeters cubed? Well, I calculate the volume of one tiny cube. Okay, it's 9 centimeters cubed. I need to fill a total volume of 81 centimeters cubed for the whole prism. And so I divide it by 9 centimeters cubed per cube. And we get 9 cubes, because 9 times 9 is 81, I think. Okay, hopefully that helped. Let me know if not. Hey, if it didn't work, you get your money back. Okay. And hopefully you come check it out. Let's see if we got any other ones. Nothing new in there. Got a notification. Interesting ad. Is that who I just helped? Actually, let me... Oh. Where's this link? Copy. Paste. Let's go. All right, so we're gonna do another one. Yeah, give me some more Calculus 1 stuff. I feel like Calculus 1 is pretty, it's like advanced enough to be interesting, but like I've done enough of these problems that I don't usually spend a whole lot of time messing up, which is nice. The value V of a machine t years after it's purchased is inversely proportional to the square root of t plus 1. Okay. The initial value of the machine is $16,000. Write V as a function of t. The value V of a machine t years after it's purchased is inversely proportional to the square root of t plus 1. Okay. Find the rate of depreciation when t equals 1. Okay. Huh, that's weird that you got this one wrong, but this one right. So V is proportional to, inversely proportional to the square root of t plus 1. So they tell you the function takes this shape. This means that V is equal to some number k times 1 over the square root of t plus 1. And so what we can do is, let me put this in function notation. So this is V of t. This is V as a function of time. I know that V0 at time 0, when you first buy it, is... I know what that's equal to, so this is, I'll just substitute t equals 0 in here. I know that this is 16,000. So this equation, I just need to solve for k to figure out what the constant of proportionality is. And if you look closely at this, this is like 1 divided by the square root of 0 plus 1. 0 plus 1 is 1. The square root of 1 is 1. So this thing, which is 16,000, is actually equal to this. And that makes sense, right? Like that makes sense to me. That passes the sniff test. So we go back, we put this in for k here, and we get V of t is equal to 16,000 divided by root t plus 1. Okay, root t plus 1. So that's what we want, 16,000 over the square root of t plus 1. Okay, so find the rate of depreciation when t equals 1. We want the rate of depreciation when t equals 1. So this is the value which is depreciating, so that is the depreciation function. We want to find the rate of that thing. The way you find the rate is by taking the derivative of that mess. So V of t, we just found out was 16,000 over root t plus 1. And we want to find v prime of t, the rate of change of the value. So this is going to be 16,000. I'm just going to rewrite this one. This is 16,000 times t plus 1 to the negative 1/2. Sometimes it's easier to do derivatives like that. So I'm going to use the power rule. I'm going to bring down that exponent. We got negative 1/2. This is going to be times t plus 1 to the negative 1/2 minus 1, which we can simplify, and times the derivative of the inside, which is just 1. So we've got negative, need another 0 there, negative 8,000, just canceling those, times t plus 1 to the, this is negative 1/2 minus 1, this is negative 1/2 minus 2/2, which is minus 3/2. Yeah, so this is the function v prime. That's our rate of change of depreciation at any time. Now to evaluate this thing at t equals 1, we just do v prime of 1, which is negative 8,000 times 1 plus 1, negative 3/2, which is equal to negative 8,000. I don't like that. I don't like that at all. There should be no way for that to be negative. No, that can be negative. It's the rate of depreciation. Sorry, I was thinking of the actual depreciation. This is over 1 plus 1 is 2, and I want the square root of 2 cubed, which is 8. Okay. Yeah, we can clean this up further. This is negative 8,000 over, so that is 4, so 2 root 2, and this is negative 4,000 over root 2, which is negative 2,000 root 2. If there's any question on that arithmetic there, let me know. I'll check it again. So same thing, we have to do it with 3 now, which should be easier to calculate. So v prime of, actually let me make sure, rate of depreciation, yep, at 3. So this is negative 8,000 times 3 plus 1, negative 3/2 equals negative 8,000 times 4 to the negative 3/2, which is going to be negative 8,000 times 2 to the negative 3, which is negative 1,000. Yeah. Does it say exact value? You made it. Hey, welcome to the stream. Thanks for posting stuff in the chat too. I think it helps the algorithm to have people participate. Smash that like and all that stuff. Obligatory. That I should say that. I forget though. Okay, so yeah. Let me just kind of zoom this out and I can walk through the whole thing again. Actually, why don't I ask you, are you able to rewind right now, or does it make you wait until I finalize the stream? I'm not sure how bad the lag is on this, so let me know. Anyway, this is the whole problem, but I would be glad to walk you through it if you can't rewind the stream. So just let me know. Okay, yeah, cool. So, if you want to jump back, what I'll do is I'll find another question to answer in the meantime. Sorry, I got the hiccup suddenly. And I'll just take yours off the screen, but I'll save it. So let me rename this layer to Christian. Okay, so I threw your name on there so I can pull you back anytime. So yeah, rewind that and just let me know if there's anything that's unclear in my explanation. I can go back and do it over. Or if you submit it and it doesn't, if I made a mistake or something like that, just let me know. And I'd gladly do it again. Or if you have any other questions, post them. Let's do your whole homework. So we want to go back. And let's get some new stuff. What does this question mean? I don't know anything about sociology. Whoa. Okay, I found a really cool problem, but this looks hard. Diameter 5 centimeter. Yeah, this is really interesting. So I've got a circle, and the diameter is 5 centimeters. Prove that at least two of these points are less than 2 centimeters apart. I wonder if this is even true. Let me try to think through this. So what if we go and like, how can I maximize this distance? So like here to here, that's 5. Here to here. So what would this be? This would be 2.5 plus 2.5 squared. Okay, that's 2.5. Oh, I see. Well, we can get more on there. So if I make, so what is this arc length? So S equals R theta. So if we were to cut this into triangles, something like that, then we get some angle here, theta. Let's not go with arc length. Let's go with, this is 2 centimeters. How many of these can I get? Well, yeah, let's go with the arc length first, because that'll give us the upper. So I want 2 equals 2.5 theta. So theta equals 2 over 5 halves, which equals 4/5. So it's got to be, the angle has to be greater than 4/5. How many, so 2 pi divided by 4/5 gives us 5 pi over 2, so this is like 15 over 2, so this is like 7 and some change. Blah, blah, blah. Yeah. So the most we could fit around the edge is 7. And then okay, that's interesting. Let me just check in with Elijah. So yeah, let's say, we can at least fit 7 around the edge. So let's say we get 7. I don't know. It's impossible for me to divide this into 7s. So that's 3, 4, 5, 6, 7. So we could probably do even bigger. I'm gonna get this like approximately decent. So 1, 2, 3, 4, 5, 6, I don't know, 7. Something like that. These are evenly spaced. Then all we would need to do is get 3 in the middle. 1, 2, 3. So I think my gut tells me that's the optimal spacing. Like, wouldn't you want to do that? Yeah, I would think so. But maybe that's a little kind of dumb way to think about it. So let's go back. So let's say here's a circle, and it has radius 5, or radius 2.5. So I'll draw a chord across the middle. So here's a diameter, and we want to draw another circle of radius 4. So this is a circle of radius 4-ish. Yeah, I don't know. The 4. Okay, and then I'm going to paste that, and then move, no. Control C, Control V. Okay. So we could put several on there. Right, so you could do like so you did 1, 2, 3, 4. So we need to make that work out. I don't know if that could work out. So let's go. matters that this is perfect, but my perfectionist streak is coming out. Alright, whatever, that's fine. Oh no, jeez. Add a layer. Okay, good enough. It's gonna be, I'm gonna change the color of this to be, oops. reply to somebody. Go to channel, add moderator, report move. Okay, so which problem was it again? Which problem was it again? I think this is the most concurrent people watching that are strangers ever. Yeah, so thank you guys so much for watching. When we see roast me on two wings, let me see if I can find you. Is it this one? It's got to be this one. Oh. Man, how is that not right? Oh. I know why. Because it's wrong. Yeah, it's just wrong. Let me fix it. Female dogger. Okay. Yeah, I'm sorry, female dogger, or oh my god, gaming. OMG gaming. I think I'm just wrong. So the cube, like the individual cubes, should have a different volume. So they should be 3 times 3 times 3, which is 27 centimeters cubed. And we need to fill 81. So it's 27 centimeters cubed per like individual cube. And we need 81 centimeters cubed total. So how many of that will it take? Yeah, I'm sorry. I just like did bad arithmetic. I really don't know how I pulled that off. This should be times another 3. It's 3 cubes. Because it would be 27 plus 3. Yeah, 60, 21, 81. It's 3 cubes. I really, really, really don't know how I messed that up. Thank you for coming back and actually like posting something and telling me I messed it up. Man, I really, really, really don't know how I did that. And you even like you left 9 in there so I could see what you tried. That's my bad. I really don't know how I pulled that off. I guess like I'm more tired than I thought. Although you know what, like I make mistakes with arithmetic. I do this all day. This is my job. I just tutor for a living, and I do arithmetic in my head nonstop. I make mistakes. It happens, you know. But yeah, thank you for being persistent with that. That's like seeking help, being persistent. That is the stuff that's going to make you successful in math. So you're already way ahead of the game. I'm doing this problem now here, and I have no clue what I'm doing, so I'm just trying to figure it out. If you guys have any suggestions on how I can solve this, let me know. Hey, you're very welcome. Seriously. And if you ever have any other questions and you have enough time until it's due, send me a message on Reddit. I'm going to try and do these streams pretty regularly, so if I can find a time that is open for me that a lot of people want to come bring me their questions, I'll be on here consistently. The other thing I'm trying to do is like adopt a class. So if you have a bunch of people who are confused, like if your teacher is not, clear for your class, send me your homework and get a bunch of people on a live stream. I'll just do your homework and explain it to you. Oh, that's interesting. That's a... Hey, yeah, thank you. Seriously, thank you for coming and watching the stream. Like, it just helps the channel health get me started, you know. And I'm just trying to, like, I figured I would be rich if I could do this for free. So I'm just doing it for free. You know what I mean? So, yeah, come ask me questions and stuff. I don't know if I can answer everything, but I can help here and there. So, have a good night. I need to look up this identity though. What is this gonna be? So cosine double angle. Yeah. Cosine squared. Oh, that's cool. So no, that's not what I want. I want this one. Two. So 1 minus 2 sine squared. Okay, so this is thanks, Tom. I appreciate it. I'm not so good. I don't know. I'm getting better. I practice every day. I do this a lot. Like I'm a math tutor, so mostly I work on like high school math, like up through Calc 2. So I do a lot of math, but I'm not, relatively speaking, you know, there are people who are way better than me. But I'm a good person, and I try hard. Man, this is a wild question. So I'm thinking that, and before I even get crazy into this, let me actually check what I was saying before. I was the question at the start of the stream with the x-intercepts. Oh yeah, cool. Honestly, dude, I felt like that was the worst question that I answered because I had to use technology to do it, which I really don't like. I hope that, you know, conceptually you understood why it it worked that way. And you know, if there's ever anything that doesn't make sense in my explanation, please, you know, get in the chat and post about it. I would love to go back and clear anything up. And also, just the fact that you guys are posting things in there is going to make my channel like successful. So you're helping me at the same time, which is really cool. And if you have any other ideas of what kind of stuff you'd like me to do, let me know. You're the audience right now, so you guys get to decide. Yeah, and it's all love, so, you know, whatever you guys need, just let me know. Gee, I'm like, this is getting me, but I want to make sure. So originally I had worked out, basically this problem is, I've got this circle, it's diameter 5, and I need to put 10 points in there and show that I can't keep them all 2 units apart, 2 centimeters apart. So originally I calculated that I could fit 7 on the outside. And I'm trying to think about how did I figure that out. So I think I used S equals R theta, and I wanted the arc length to be 2, just to estimate how many I could get around there. And then R is 5/2 theta, S equals R theta. And so I figured this was theta equals 4/5. And so I wanted to say how many of these angles do I have? 2 pi divided by 4/5 gives me 5 pi over 2, which is like 15 divided by 2. So 5 pi divided by 2. So that gives me almost 8 of these things if I use arc length, which it should be less than that. So I think 7 is reasonable. But then if I have 7 of them, I know the distance is exactly, let me make sure I'm on radians. I am on radians. I know that if I have 7 equal angles, it's equal central angles, then I have 5 sine of pi over 7, which is more than 2. Okay, so we're cool. So I'm glad I checked that. That makes me feel good about going forward. So this is greater than 2. So those are like evenly spaced. And then now the question is, how can I get 3 more points on this? That's very interesting. Okay, so if we made a point, and so if this is like, I don't know, it'd be like somewhere in here, right? And this point is, oops. So I don't know, it's like something like this. And what I want is this to be exactly 2. Because then there would be like another one here and here. So this would go like all the way around, and that would make a circle of these things. And that would be, that diameter would be interesting to know. So I want to know that. This circle one that I'm on now, yeah, if I solve it, I'll really try. Although maybe a good thing to do would be to resurrect it on like another day. I don't know. How long are you watching the stream for? Or which one? Because this could take me, like, I feel like I made progress on this question, but this could take me forever. I honestly have no idea if I'll be able to solve it. Because it's like proving something can't be done, you know? Which is a little weird for me. I've never really... I don't do that many of these kind of problems. And even then, like, how do I prove that I have the optimal thing with my method? So, yeah, this might be beyond me. I guess, how could I do that? Oh, that's a good question. Let me look. It doesn't say. I think I can post the link to this. That's where I found it. So this, I think you came from the Homework Help subreddit, and this comes from the Cheat at Math Homework subreddit, which is pretty honestly, it's pretty cool that you can just go get someone to help you, and like you don't have to know how to do it, you know, because I understand a lot of people come here and they need help because they just need to get out of this class, and they're not trying to do math, you know, which for me that's a major bummer. Like, I want everyone to do math. I think math is really cool. I get a lot of personal enjoyment out of it. It makes me feel capable, and you know, there's a lot of stuff that comes from doing math for me, but you know, not everyone feels that way, and they have teachers that yell at them and stuff. So this particular subreddit's dope because you can just, people will just help you. You know, they don't have to like shame you for not trying, show your work, like all that junk, which is cool. Yeah, Reddit's amazing. I love it. It's one of the most underrated social media websites. I don't even think of it as social media, but like in, let me think. So when I was like 18, so how old would I have been, or what year would have that been? So 20 years would have been 2007, so like 2005, 2006, no. Okay, so it would have been like 2007, 2008. So like 2007, 2008, there was this awesome forum called the Brazilian Jiu-Jitsu forums. It was like BJJ forums or something. And I spent so much time on that forum. I spent so much time. And this reminds me of it because the community was amazing. You just constantly posting stuff. B, they asked for the answer to be in decimal form, so I converted the answer you got into decimal and it said it was correct. Oh, okay. Yeah, sorry about that, Christian. Whenever I'm doing problems, I like exact values. I don't like decimal. Like, you can see this one I'm working on now. I knew that was like approximately 2. I wanted it to be greater than 2, but I went through all of this mess here, not even knowing what would happen, and then got to this point where I was like, oh, that's like a, or I didn't even get there. I noticed it. I was like, oh, that looks like a half angle identity. Let me see if I can make this beautiful, just because I wanted this nice, like this thing is equal to this thing, and I wanted to find that. Substitution, like this is this. So I went through all of that for no reason other than aesthetically. I don't like approximations. I don't like decimals. So whenever I do it and I get to that exact value, like this number, I don't want to punch this into my calculator and say, oh, this is approximately 2 point. It feels gross for me to do that. And then when I'm helping people, I just forget. Like, let me find you. You were here. Yeah. Oh, word, yeah. You're talking about this number. Yeah, like I would never type that in my calculator of my own free will. It's only when, and then I don't read the instructions. I could do this a lot better is what I'm trying to say. Yeah, are you done with that homework? Like, do you have any other problems from there? Because I think I'm spinning my wheels on this right now. Right now, like this one, I'm supposed to be disproving it, and I'm trying to prove it, hoping I'll learn something in the process about how to disprove it. So I'm nowhere even close to this. Okay, so that is not the most efficient packing. Yeah, I guess I know a little bit of Python. I did that Google Foobar challenge and I got to level 4, and then I was like trying to do the there's a program that has Markov what kind of Markov state is it? It's like Markov like condensation state or something like that. Essentially, it's like you have a starting condition and you do this thing like recursively until it gets to a stable state in the system. And it required me to have to like hand code matrix operations for a matrix of any size and then optimize it in this. And I was just like, oh, way past my ability. So like I can do little stuff, but I can't really code. I am able to code little, tiny applications for making like simulations or whatever if I'm trying to figure a problem out with math and I need to generate a bunch of data to help like guide my intuition. But it's really limited. Like I never any kind of like useful applications that anyone else would care to do. But if you have programming questions that are like entry level, I could probably help you. Oops, I'm on the wrong. So I'm trying. I failed to prove it with this method, which doesn't disprove. So anyway, this quantity was like. This was the angle I would need to get exactly 2 for the arc length, and oh, wait. No, that's the angle, so 2 pi divided by that. Yeah, it's less than 3. So I don't think I could fit 3 on the inner circle of this, which is what I would need. I wonder if I could do center and then 3, or as tightly packed as possible, and see if I could get. But I know that wouldn't work either. Well, I don't know if it wouldn't work. So what I'm doing now is I'm like looking up. This is like a specific case of a sphere packing problem because a circle is like a 2-dimensional sphere, and then you were trying to think of like what's the most efficient packing of a sphere. And it's not even really a sphere because, or it's not even really a circle necessarily because they can overlap. It's just that the distance between any, like if I give the set of points, which is 2 away from this point, right, which is the center point, that's a circle. So everything is 2. Every point on the circumference is 2 from that. So then I can think of like a lattice of circles, and that will help me understand the packing. But I don't know how to. Maybe if I choose a point and get the maximum density from it. That's okay, so that's the center, still like middle out method. But does that prove anything? that's interesting. I think it does. So okay. So I'm going to argue that the densest packing would be to pack around this point. So let's say we have a circle with, you know, some radius. It doesn't matter what it is. Here. All right, so this is a circle. And I want to get the most number of balls that are maybe that's not even the way to go. Maybe triangles is the way to go. Okay. So let's say that here we have 2 pi over 3, which would be like a third. I can't even split something into thirds. So it'd be something like that. So this is 2 pi over 3, and then I want this distance to be exactly 2. So all of these distances would be 2. Thanks. Have a good night. Yeah, I think I'm about to fall out too. Maybe I'll dream on this one. This is a cool question, but I think I'm stumped for the night. All right, y'all. I'm gonna sign off. Let this person know that I did not finish their homework. All right. Good night, everybody. Thanks for coming to watch. I really appreciate like coming and helping out my channel. You know, that's huge. This is probably my I don't know if this is 4 hours and 11 minutes average watch. That can't be. Oh no, it's 34 playbacks. Yeah. So, but this is, you know, the most watch hours I think I've had, like at any one time. So that's dope. The most successful stream. Yeah, that's huge. So like, whoa, that's like 2 hours of watch time. Big. Oh man, 8 likes. This is like one of my most successful videos ever. So lots of love to everybody. Thank you.